Hi, this is Professor Guyad with Middlesex College, and we're going to be talking about data structures today, specifically stacks and queues. So the concept of a stack, it follows the principle of LIFO, last in, first out. So if you can imagine a stack of books where you put one book, the first book on the table, and then you put the next book on top of it, and then a third book on top of it. The first book that's going to come out is not the one that we put first in, right? The first one that's going to come out is going to be the last one that we put in. So the books, if they were taken off the stack, would come off like this, right? Boom, boom. And then the first one that was put in would come off last. So last in, first out. And then the concept of a queue is first in, first out. So if you imagine a line of people at the grocery store, the person who is first in line, right? And then there's like a person second in line and a person third in line. The person first in line is going to pay for their goods and they're going to be the first ones to leave the line. And then the second person is going to be next and they're going to be the next person to leave the line. So first in, first out with queues and last in, first out with stacks. In terms of implementing stacks and queues in Java, since insertion and deletion on a stack are made only at the end of a stack, right? When we insert an element on top of a stack, it's happening at the end of the stack. And when we delete it, it's also happening at the end of the stack. It's more efficient to use an array list than a linked list. And for a queue, since deletions are made at the beginning of the list, but not insertions, it's more efficient to implement a queue using a linked list rather than an array list. So we're going to now see that. I'm going to share my screen, and we're going to take a look at stacks and queues in Java. So this time, yeah, there's a slight difference. You're seeing Eclipse rather than Visual Studio Code. I just like to change things up a bit. So I've implemented the stack, and what I've done, I've created a new stack class, and it extends the array list class that's already built in, as you can see, in the Java library. So we don't have to do much with the constructor because when we declare the stack, we're going to just be doing the various tasks, the various operations that you do with a stack. And we're going to take a look at those right now. So the three main operations for a stack are push, pop, and peek. Push means to put an element on top of the stack. And just if you're wondering what this is right here, we're implementing an integer stack rather than using any data type. We're just defining the stack for using it with integers as opposed to like having like string stacks or things like that. It really doesn't matter for our intents and purposes in this video, but I'm just letting you know about that. So that's why I was bringing that up, because that's why I'm pushing an integer on top of the stack. And that's why there's an int here as opposed to a more general term we'll see with the queue when I show you the queue. So when I push, that means you're putting a new element on top of the stack. So it takes an argument, int, the new number, and we're implementing it using the array list library. The array list library has the add function, right? And we're adding the num. Great. Pop is when you remove an element from the stack, from the top of the stack, right? As we went over previously, and you remove it and you return it. So as you can see in this implementation, we're using the dot remove of the array list library, and we're removing the element at the top of the stack. That's what the this.size -1 is referring to. Peek is you're just taking a look at the top element of the stack. So that's why we're using .get as opposed to .remove. So we have the same thing, this.size -1, but we're using .get of the array list class as opposed to the .get method of the array list class as opposed to the .remove method. So those are the three primary methods of the stack class. And here I just created my own custom print for the stack class because I want it to be shown vertically, as opposed to how it's usually an array list is usually printed horizontally. I want to print vertically so you can see, like we showed the stack of books, right? The vertical stack. So that's going to do that for us. So here in the main method, you can see that I create a generic stack and I push 3 numbers. So 5 is the first one, and then 11. So 5 will be here, and then 11 will be here, and then 7 will be on top of the 11. And then when I do dot pop, that's going to remove the 7. And then when I print the peak, that should show us the element at the top of the stack, which should now be 11, right? Because I popped 7 off of the stack, and now when I peak, 11 should be at the top. So when I run this, I should see 11. And I do. Now, when I comment that out and I just print the stack after the pop, so we have 5 at the bottom, 11 in the middle, 7 on top. Then I pop the 7 off, and now 11 is on top and 5 is on the bottom. And then I print the stack. It should be 11 at the top and 5 on the bottom. And as you can see, my custom print method is showing them vertically, which is what I wanted so that you can see more clearly the stack. Great. So that's the stack class that I created based on the array list class. Now let's go over to the queue. The queue is going to be based on linked lists for the reasons specified earlier, that deletion happens from the front of the list, from the front of the queue. So we want to use a linked list, whereas adding using NQ happens from the back of the queue. And so we wouldn't want to use an array list for that. We would want to use a linked list. So for this class that I'm creating, I'm using the generic E. This is a generic. So it's not string, it's not int, it's not char, it's just any of those. So that's the difference with this one and the stack, where I just specified it. I just defined it for integers. So here are the 3 main methods for the 3 principal methods for the queue. NQ, which is adding to the back of the queue. So we just use the dot add method here of the linked list class. And you can see here that this time I'm using a generic something. It can be an integer, it can be a string, it can be a char. So that's NQ. DQ, as we saw in my example of the grocery store line, DQ, the first person who came into the line is going to be the first one to leave. So DQ is removing from the front of the queue. So here we just simply use dot remove of the linked list class. And then get size is just it returns an integer, right, of the size of the queue. Great. So let's see it implemented. We instantiate a queue, and we NQ 3, 9, and 4. So 3 should be at the beginning of the queue, 9 in the middle, and 4 in the at the end of the queue. So let me comment these out so we just take it one step at a time. So when I print it, it should be 3, 9, 4 in a line like that, right? Just like that. Yep. Then when I do get size, it should show us the size of the queue, which is 3. Yep, we got that. Now I'll just comment out get size because we don't really need that anymore. And then I'm going to do the DQ. So this is important. We know that from the queue, different from the stack, the 3 should be removed. The element at the beginning of the queue should be removed. So when I do DQ, the 3 should be removed, and we should just be, when we print the queue again, we should just be left with 9 and 4. Let's see that in action. Beautiful. That's exactly what we would expect. Now let's add another element. Let's do NQ again, Q.NQ. And let's add whatever, it doesn't matter, 77. And then we print the queue again. And we run it. We should see 9, 4, 77. Yep. And then when I DQ, we should see, and I print it again, we should see the 9 removed, and it should say 4, 77. Beautiful. So we know that our stack and queue classes are working as they should. Let me stop sharing. This has been a lecture on stacks and queues, stacks being built off of and extending the array list class, and queues being built off and extending the linked list class. Thank you for watching, and I look forward to seeing you in the next video. Bye.